Please welcome Underflow.
Howdy, folks. First off, I'm really sorry I couldn't be there in person this week. I had a medical emergency come up over the weekend and had to scrap all the plans this week. So I wish I was at Hacker Summer Camp with you guys, and I'm sorry I'm not. But thanks for coming all the same. This talk is kind of a roll-up of the last 2 years of work I've been doing in the background. I kind of quit speaking a few years ago, so this one doesn't count. But this is a chance for me to kind of present some of the things I've been working on for a while, and hopefully, be able to share some tools that you guys can use as well. I tend to have a habit of talking quickly and mumble a lot, so I'll try to go a little slower. But if for some reason the audio gets garbled, throw something at the laptop and I'll get the point. So with that, I'm going to get started. My background is doing pen testing work, vulnerability research work, kind of hacking all the things for a bunch of years, probably like 20 at this point. Lots of time running exploits, writing blogs, white papers, doing research, all that kind of fun stuff. I've spent about, 6-7 years off and on doing internet scanning projects of various sorts, both for employers and as personal projects, and getting arrested or threatened to be arrested quite often as a result. And I started a little pet project lately called Fathom 6, which I'm putting that name on these slides. This is a little bit different than your standard, like here's a really cool tool you can go up and use, because it's not just a tool you can download and install. It's more of a whole platform you can build. Instead of it being something like Recon NG or one of the newer tools out there like Aquatone, this is more of like a giant bucket of Legos that you can just pick up and play with and build your own stuff with. I'll walk through some of the ways I use it and kind of some of the cool things you can do with it, but it's really going to be up to you guys in terms of whether you get any value out of the tools and the data and so on. It does require some setup time, and it does hurt a little bit to get all the servers and everything else up and running to run this thing, but overall it's not super expensive to get rolling. And it is really valuable once you start, making use of the system. One of the things I really don't like about the way that most Recon works these days is that it really depends on having access to third-party services you can query. And I don't know about you, I don't like telling every third-party service on the planet, especially ones run by random hackers, that I'm testing a particular bank as part of my work. So I'm really kind of gun-shy about using those third-party services for lookups. As a result, I've been pulling all my data locally for a number of years, and I've been finding better ways to pull data in that's cheaper, faster, better, that covers all the things I want to get out of my own reconnaissance without having to go through and either brute force DNS for 10 hours or send queries off to 1,000 random sketchy websites. So the goal of this whole thing isn't just do red team work, it also helps you with blue team, with monitoring, with pen testing, with even legal objectives. I've been using this stuff for everything from M&A all the way through to monitoring of my own domains for typo squats, the company I work for, and kind of everything in between. So we'll talk about some stuff. There's almost shells in this talk. It doesn't actually drop shells, but pretty close to shells. So really, that's it. It's how to make your security work better by using lots and lots of local data that you can get mostly for free or cheap. When I first submitted this talk to BSides, I did it under a random handle, and I didn't really expect it to get accepted. So shame on me, and I've had to bust my ass to actually get the talk up and running and all the tools together in time. But there are 3 new tools that were released in the last few weeks that are pretty good that I wasn't aware of when I submitted the talk, and definitely worth checking out. So if it looks like I'm ignoring these tools when I go through the rest of it, it's because they didn't exist when I started on the deck. X-Ray from Evil Socket, Aquatone from Mission Riskin, and Website from Christopher Grayson are all pretty neat and do a lot of stuff kind of around this space. One of the nice things about Recon tools in general is that they don't really replace each other. They're all really more complementary. Some tools are going to be better at some other things. If you're looking at DNS discovery versus, third-party port scans, getting more data is always better there. It's not like, Shodan replaces everything else you do. Shodan's a great thing to bring into everything else you do. So the problem space around this and kind of where I really got started is that most companies I do pen test work for don't really know what their footprint is. I can probably see you guys if you raise your hands. How many of y'all have done a pen test where the customer didn't even know what they had? The video might have frozen. I'm going to assume some, but I'm not getting updates. All right, so one thing I often run into is customers will say, okay, there it goes. Woo, video. A lot of times customers say, well, we've got these 5 websites and these 2 applications, and that's what we want you to test. And we're like, that's great. What do you want to do about these other 2/Bs you have over here and all these little tiny site-to-site VPNs and external subnets and broadband networks and this stuff? And they go, hey, where'd you get that from? And so a lot of a lot of the data that we got those subnets, those networks from, is coming from things I'm going to talk about today. And oftentimes that's actually what gets us in. One of the corollaries of this is companies who haven't been testing all of their assets often do a pretty good job on the ones they know about and an absolutely terrible job on the ones they don't know about. So anytime we do a pen test and they've been getting quarterly pen tests by some large consulting practice, everything's pretty much scraped clean. There's no low-hanging fruit. There's no unpatched stuff. It's basically a few custom web apps with some maybe low-hanging web app bugs, but nothing really easy to break into. We generally have to use 0 days in commercial products that we find as a result of doing the test, or we have to go find assets that they didn't know about that they didn't know they should be testing. So I think one of the more recent ones I worked on, it was a company with a couple /Bs, so tons of IP space to start with. There wasn't really much on them though. There was pretty much completely firewalled off. What we did find, however, was a whole bunch of little small broadband networks. And those broadband networks were a little bit difficult to identify in the first place because the errand data was out of date in some cases. The ripe data was out of date in the European. But we ended up finding a subnet full of Cisco routers where there was a high root shell on a high port. And Cisco to this day still has no idea why that Cisco router had a root shell on a high port. It was related to the Patriot FPGA piece. So that was kind of a fun test where this really big company that had been tested every quarter forever thought they had everything locked down, and we still managed to root their data center through this obscure Cisco bug that we just happened to find doing a full port scan. So oftentimes to do a pen test scope, it's not really clear. There's a little bit of echo on the mic. Any chance you can mute the local microphone on the laptop? Cool, thank you. You don't really know what the scope is. No problem. Cool, okay, great. And I'll wave if I can't hear you and you're saying something. So generally, like most customers don't know what their pen test scope is. You kind of have to tell them, and then you have to fight to convince them it's actually their scope. So in a couple of cases, we went back and forth 20, 30 times with the same customer. Like, we really think these IPs belong to you. They said, no, they definitely don't belong to us. Like, they have your servers on them. They've got your host names on them. We can get a shell on them. They probably belong to you. Anyways, long story short, people generally don't know what they actually have, especially companies that have bought other companies who then bought other companies and so on. Once you get to 3 or 4 levels of M&A inception there, nobody who's left on the IT team has any clue what's still around. So this complicates future M&A, it complicates IT management, security testing, monitoring, blue team, red team, everything in between. There's a lot of pretty good solutions out there for how to discover assets for a given company. DNSDB, which used to go by RobTex, Pass2Total, of course, Farsight, Pass2DNS. OpenDNS is an umbrella product, which is mostly used for instant response, but does a lot of asset discovery as well. And there's tons and tons of really great open source OSN tools out there. Not just new ones like Aquatone, but things like Recon NG, even Metasploit does some of that stuff as well. You can also do manual lookups as well, querying third-party web services, checking who is, and so on. So that's really the problem space I'm trying to solve with the tools I want to talk about today is how do you find everything that belongs to a company, and how do you find stuff that's really obscure and really tough to find through any other mechanism. So the biggest challenge right now with how Reconnaissance is done today is it's really dependent on third-party APIs and services. You have to go sign up for 1,000 things, and every time you use any of these tools, you're sending off the identity of your client or information about your own company to whoever's running these tools. And I don't like that, and they don't really work very well. And if you're trying to find a needle in a haystack, try to find one server that happens to belong to a company that may not be part of the primary domain, that gets really difficult. You really just can't do that. There's no way to get there. So a lot of what I like to do is sift through every host name on the whole internet looking for a reference to a company name or to a product name. Even if it's not tied to that particular domain name, it gives me a much, I get a warm fuzzy that I actually did a better job of discovering all their stuff in that case. And you can't really do that with third-party APIs and tools where you're doing, individual queries in those cases. Another challenge with these tools, they really, their ability to provide comprehensive results is drastically different based on where they get their data from, what technique they use to get it. And so if you need to go correlate data from, Shodan and Farsight and this and this and this and that, tools like Recon NG do a pretty good job of gathering data from lots of third-party sources, but having to merge all those together and trying to figure out what's authoritative, what's not authoritative, it gets pretty complicated. these tools, especially when they're related to kind of third-party assets, irregular scans or regular lookups, they don't really give you a real-time picture. I don't want to pick on a particular vendor, but there's one vendor that gets used a lot for this stuff where they've got 3 months of data for any given company sitting in the database, which is great, except for half the data is no longer useful when you go do a pen test. Half those web apps aren't even on the same IPs, half the servers aren't up anymore. Stuff is just changing way too fast these days to be able to depend on tools that have a 3-month time window for the results that you query. And that kind of leads into the next piece, which a lot of the kind of rapid changes to infrastructure and applications is happening because of deployments to clouds and due to things like automated deployment tools like Kubernetes and Docker and so on. So the more kind of dynamic infrastructure gets, the harder it is to actually find this stuff at a given time, at least without credentials to all the different tools that people use. So if you're on the DevOps team, you probably have a good idea of what your DevOps team handles, but you probably have no idea what your other teams, your marketing teams, your cloud teams, and a lot of IT teams have no idea what their DevOps teams are doing in some cases. So that's kind of where we are today. You've got kind of your old school solid infrastructure that doesn't change very often, but is pretty hard to find, kind of the squirrely bits like the broadband IPs. Then you've got the whole other pile of it, which is the dynamic and rapidly changing cloud infrastructure and dynamic deployment tech tools. So this kind of goes into kind of my philosophy for this stuff, which, I don't like hitting lots of third-party services. I don't want to have to fight to get access to the stuff. I want to have it all locally all the time. And it's, computers got fast, hard drives got big. Like I can get a 10 terabyte hard drive for like $300 right now. I actually have lots of them. So it's pretty cheap these days to actually keep a pretty sizable amount of data locally. And if you process the data in the right way, it's actually pretty fast to look up as well. You don't need to have a server with 200 gigs of RAM just to be able to query, stick it on Postgres. Because one, don't use Postgres. It's a terrible tool for this stuff. So that's a long way of saying that is if you can start pulling all these third-party data sets into a local server and you crunch data in a way that makes it really fast to look up for your particular use case, you don't need to have a massive amount of resources to do it. You can do this for a couple $100 a month at the most. And of course, you avoid leaking target information out to the third parties, and it actually complements all your active discovery efforts. A good example of that is I like doing, using things like Sonar DNS, certificate transparency, some of the SSL cert stuff that comes out of Census.io to get a list of all the hostings for a company. And the cool thing about that is you end up seeing patterns automatically in the names. You say, okay, this is mail-01-company.com or whatever. Or you start seeing different patterns based on localities or names. And so I end up focusing all of my directory brute forcing against, okay, it's 01, let's try 02, 03, 04. So using just enough of the kind of passive external data sets to get a feel for where I want to focus my active discovery efforts. And of course, when you start finding weird stuff like, hey, there's a strange pattern to these names and it applies to more companies than just the one I'm looking at, you actually have all the data nearby. You've got all the local data to stare at. You can go dig through the whole internet trove of data and figure out, is this a common thing? Is this uncommon? Is this because of a particular third-party vendor and how they manage these types of assets? So you can really get to the root cause of some of these weird configurations that you run into. And it's fun. And there's lots of weird, interesting stuff that you can find digging through these giant troves of data that you just can't really do if you're playing with third-party services. So the whole goal of this thing is to actually build a platform that you can use to do pretty much anything with. We want domain names, we want whois, we want DNS data, TLS certs, anything we can possibly get to help us better understand a particular organization or our exposure or our target's exposure. Let's get as much of it as we can in one place and start tearing it apart and start correlating between different pieces of it. We want to be able to collect data on regular intervals, so whatever frequency that particular source updates is probably the best. If it's too frequent, it's eat all our bandwidth. Maybe we do it once a week or whatnot. But generally, let's basically grab lots of data as it's being generated, pull it all down, correlate it, discard old stuff if we need to, and don't spend a whole lot of money getting this stuff. We don't want to go spend $10,000 a month for a passive DNS provider. We'd rather just go get all the host names from all the various third-party sources that are already doing lookups for this stuff. Storage is pretty cheap. Computers have gotten pretty fast. Even the new desktop, Skylake X's have like 10 cores now. So getting a multi-core machine with 16 gigs or more of RAM is actually not that big of a deal anymore. So on that note, if we're going to start looking for data to use to build out this platform, I've kind of gone through and started doing the work there, and this is where I've ended up so far. Sonar is the REP7 project that includes like reverse DNS, forward DNS using a massive pipeline to generate the types of data, UDP scan, CCP, TLS, HTTP, all the maps. They've got tons and tons of data. It's all published for free on scans.io. You can download it, play with it, do whatever you want. Census.io is the output of the University of Michigan team that ended up partnering with Google to store all their data in a big query instance. And you can, the cool thing about Census.io is they have an API, they've got a search engine, they've got a kind of fancy website, but you can also download the 1 terabyte raw LZ4 files that are like an entire snapshot of the internet. And that stuff's awesome because you can actually download the whole thing and have your own mini showdown you can query with like zero overhead on your local box. And no one knows what host name you're creeping on or what domain name you're searching for. It's all just right there on local. So I really suggest getting census data and getting the IPv4 version of that, getting the full IPv4 raw dumps. Those are generated daily and they're over a terabyte a pop. So they're a little bit tough to do more than once a month or so. But they are really useful for getting kind of a quick snapshot of a big network at once. One of the data sources I'm going to spend a lot of time on a little bit later is certificate transparency, or as it's here, just CT. CT is really cool, and for a bunch of reasons I won't go into yet, but essentially it's a giant database of all SSL certs that have been observed on the internet, as well as SSL certs that have been issued. And kind of moving on past that, you've got CZDS, which is the new global TLDs. It's all the zone files for those. This is free. You just sign up with ICANN, and you can download all the zone files at whatever frequency that makes sense. So there's something like 1,100 zone files you can download, and you have all of the newly registered domains for all the new crazy TLDs out there. A lot of fun, free, and easy to play with. ARIN's a little bit trickier. If you want to get the bulk ARIN data, you have to sign and mail a snail mail form. It's one of the only things in this whole set that actually took like more than a month to get signed up, because you have to mail them a form, write down what you're doing with the data. They may call you back and like ask you questions about it and grill you about it, and you have to like answer all these questions. And they're trying to prevent scammers from dumping all the email addresses out of it, but in reality, it ends up being kind of a pain which is really just saving them bandwidth and hitting their WHOIS servers. So bulk ARIN data is great, but it is kind of a pain to get. It just takes a month or two to get lead time on it. If you're trying to, one of the things that drives me crazy whenever I'm doing either like instant response stuff, like if you're looking at an incident and trying to figure out what the IPs did or what was happening given time and date, is who actually owns that IP changes depending on the month and the year and the day sometimes, depending on how quickly that IP is being reassigned. The only way to basically get historical assignments from an IP that I know of that's cheap and easy is the CADA prefix to AS databases. They do a daily dump of BGP prefixes and advertised prefixes to providers. So if you see a crazy IP in your log that looks like it's Iran, looks like it's Egypt or some Middle Eastern country that doesn't really make sense for where you're seeing it, you can actually go through the historical data for the time you saw the event and see, was it actually that country or that particular assignment at that date. There was an attacker that I ran into a few times that was going after a customer of mine, and they were using a satellite range that was pointing to Jordan, but for like 6 to 7 hours a day, it got reassigned to Iraq. And then they would do whatever they're doing was in Iraq, and then they would get swapped IP right back over to Jordan again. So it was really strange where all the standard kind of IP lists out there thought the IP was in Jordan, but if you queried it at the right time, you'll see it actually got reassigned briefly during the middle of the day to this other country. So one of the great things about the CADA database is you can actually get pretty granular dumps about which owner owns which AS and which prefix and so on. And those are pretty difficult to get otherwise, unless you're like monitoring BGP full time. Just as kind of a fun ad, all the U.S. government domains, the UK government domains, there's different repositories out there where you can get the full list of all the domains that should exist. And those aren't zone dumps, but they are text files that are updated pretty frequently. And just like ARIN, you've got the regional IP allocations, things like AFNIC, LAPNIC, RIPE, all that stuff. Those are generally pretty useful. The downside there is they don't give you contact information in the bulk data. You don't have to sign up for it, but they won't give you things like WHOIS, email addresses, and the WHOIS data. But they are good to figure out just who owns what block and so on. Moving on a little bit, you've got Premium Drops, which is a weird kind of SEO site where they sell TLD dumps for ComNet, InfoOrg, Biz, XXX, XK, and US. So for like $25 a month, you get a list of all the TLDs. You can download once a day. And there's another site that popped up recently, which is www.s.io, that for $9 a month will give you about 200 million registered domain names once a day. So if you're trying to do just like typo squat matching, this www.s.io one's probably the best bang for your buck. If you need to have the zone files that have the name servers linked to each domain, which is useful for a bunch of other work, you definitely want the Premium Drops one and the CZDS dataset instead. And then finally, if you're trying to get a cheap source for bulk domain WHOIS data, there's no real way to get it cheap. What you can do is start building up a new data set from scratch. So the WHOIS XML API site will sell you a daily dump of all WHOIS for all newly registered domains. And then as you start building that up over a couple of years, you end up having a pretty good picture. They also have I think that's $250 a month. You can get a 20-month backlog history of all the WHOIS. So you can sign up for a month, get the 20-month backlog, and then get the recurring names. I've been using this for about a year and a half, 2 years. And I'm up to about 50% of all registered domain names I've got the initial whois information for, without having to do my own massive whois proxies and brute force and all that stuff. So anyways, long story short, if you hit the URL at the bottom, GitHub, Fathom6, INET, you'll see a kind of a breakdown of all these tools and where to get them and so on. But these are the primary data sources I'm going to talk about today and how to use them. So this stuff is a little bit dry, but I swear it gets more fun. So if you actually want to grab all the stuff, the quick and dirty way to do it is hit the Fathom6 INET data repository, clone it, modify the sample configuration file, tweak it to whatever you want to do, enter APIs, credentials, anything you all see signed up for in that first list. It does a lot of stuff without having credentials, like the Sonar data just downloads by itself. It also needs a set of processing tools, which are INET data parsers. Those are written in Golang. You can grab those from Fathom6 INET data parsers, and those are really parallel processing friendly. So the more CPU cores you can throw at your project, the faster this stuff runs. I run it on a 16-core box with 200 gigs of RAM, and it works great. But I also run it on cloud instances that are much smaller, and it usually chugs along just fine. Generally, the process works. You run the downloader first, and then after the download is complete, you run the normalizer. The downloader will basically grab whatever the raw formats are from these different providers, and the normalizer goes through and cooks those formats into something you can quickly query for common use cases. So if you just run INET data bin daily.shell, it'll do all that stuff for you. And again, more RAM and more cores help. Generally, when you first start this process, you run daily.shell once, and you wait maybe a day or two, depending on how much stuff you're pulling down. And then once it's kind of the first chunk has been pulled down, then you start adding it to your cron job and running it actually daily. It takes a little while to bootstrap, though. So a lot of the raw data is great. I mean, most of these data files that you can pull down are just big text files and compressed lists. So you can use all the standard Unix tools like sort and grep and all that fun stuff, zgrep and whatnot, and that's great. The challenge, though, is if you're trying to say, give me all the data for this particular subnet range, this particular CIDR, like 888/24 or something like that, or give me every reference to any give me every record in this particular domain name. So whether it's fathom6.io, whether it's BSidesLV.org, give me everything within that. The cool thing about the way this is structured is that it doesn't really care whether you're asking for a subdomain or an entire TLD. It's generally fast enough that you can get all those results pretty quickly. So if you want to do things like research into a particular country's TLDs, domains, or an entire block of like /8 or bigger, the tools support that just fine. So in terms of where it actually starts crunching the raw data into much faster formats, Sonar DNS is one of the ones it really focuses on. That allows you to do things like give me every subdomain within a particular domain instantly. You can also do things like show me every domain name that points into this particular subnet. So the way that the INET data parsers tools and the INET data package works is it will create an inverse and create a forward lookup table and an inverse lookup table. So it ends up creating basically two duplicate databases that are keyed backwards. And that lets you basically be able to find those inverse relationships between a domain name and an IP or IP range and a set of domains and so on. It also takes a lot of the raw data files and sorts them and lets you correlate. For example, all the name servers for a given domain name will get matched up automatically as part of the process. So outside of Sonar, it also does that for CZDS, Premium Drop, CT Log, Census.io. If you want to make a mini Shodan and basically just turn all of the IPv4 census data into one big queryable file, this massive MTBL database, this is how you do it. So if you actually want to set this thing up, the best way to do it is get a box with at least 4 cores, 16 gigs of RAM. If you can afford something bigger, great. You can also take a large instance, like get something with like 16 to 24 cores with half a terabyte of RAM if you want to. Bootstrap the whole thing on that, and then downgrade it or snapshot the image, and then bring it back up with much smaller resources later on. So if you're using a non-local server for it, that's one way to get there. I'm in the middle of digging a 4-foot trench around my entire house to run 10 gig fiber to everything, and I've got my new server room being built. So that's my solution to it, but it's a little different. I know everyone else doesn't go quite as crazy with their home IT gear. I keep running out of power, so I have to run a new service line to the house too. It's been fun. So I know everyone else doesn't necessarily like doing that stuff. So if you need to use Google Cloud for it, for example, their N1 high MM4 instance is pretty good, and $122 a month to get off the ground. You can always, once you've got the initial bootstrap data, you can always downclock it to something smaller and go from there. For storage space, it's about 1 terabyte is about the minimum for hard drives. You do want to have a fast working directory for it to use, like SSD or NVMe or RAM disk if you've got tons of RAM, just because that speeds up a lot of the stuff significantly. As far as compatibility of the tools, Ubuntu 16.04 will save you a lot of trouble if you use that. You could probably port the stuff to everything from FreeBSD all the way to whatever, but if you're lazy and just want it to work, that's an easy way to do it. If you enable every single possible data source, including like the terabyte census IPv4 data sets, you've got credits to every possible thing out there, you're probably looking at about 2 weeks to bootstrap, which is about 3 to 4 days on a good connection to download it all, and about 2.5 weeks with 4 to 8 cores to crunch it all into something you can actually process. But you only have to do that once at least. So it's kind of a pain in the ass to get it off the ground. I may look at doing, for data sets that I'm allowed to share, I may put up a like BitTorrent for the process data sets just to bootstrap these things. Certificate of transparency in particular takes a long time to bootstrap. It took about, I think, 4 or 5 days last time, and about 800 gigs, I think, of storage space. So, and the output of that is pretty small. I think it only ends up eating about, I don't know, 100 gigs total of crunched output when it's done, but it needs a whole lot of temporary space to pull it all down. Anyway, so if you use kind of the lighter options, it's pretty much a couple hours the first day, and you should be good to go. Like the Sonar DNS is probably the biggest one to pull down. I think, let's see, I've got a little instance here that's been chewing away on Sonar DNS with 4 cores for a few hours now, and it'll probably be done in a couple hours. It just does a full-blown like dump, conversion, sort, split, flip the CSV from value key to key value, roll up on those values, and generate 2 MTables back out. But we'll go into some details of that a little later. So one of the challenges you run into doing any kind of large-scale data processing these days is that IOP, like I/O speed, is way more expensive to improve than CPU cores. If you want to replace all 10 terabytes of hard drives, spinning hard drives in a server with 10 terabytes of SSDs, it's pretty freaking expensive compared to just putting in a CPU with more cores or getting more low-end machines together. So the way I've been looking at this is because IOPS are so expensive to provision, and because I don't want to spend like 30 grand on freaking flash drives, I just want my stuff to work for a couple $100 on a server or cheap VPS. I end up using inline compression utilities for every step of every process in this thing. So if you dig into like the iNet data batch scripts for how to process the source files, even the sort command lines end up using PIGZ, which is a parallel gzip utility, to compress the temporary files, because it's still faster to spend all your cores compressing those temporary files than it is to write them out to your hard drive, because the hard drives are so damn slow compared to it. So it's one of those kind of weird things where the further I dug into this, the more it made sense to really compress all the data between the pipelines as opposed to trying to just depend on fast storage. As you start looking to the data formats for this, LZ4 is one of the best ones out there today for parallel processing support and for compression rates. BZIP2 is great, same as XZ, and they both have parallel utilities for it. The challenge is, though, is that those compression formats are not widely supported within other third-party tools. So if you want to take a file that's been parallel compressed with BZIP2, you can't give it to Hadoop or any of the Java parsers because it doesn't support the parallel block format. So at the end of the day, you're kind of stuck using gzip as your internal format for a lot of the stuff if you have any compatibility concerns whatsoever, or unless you're willing to rewrite your whole stack of some third-party stack to do any kind of big data mining or data lake stuff with it. So the magic bullet I'm using for a lot of the fast lookup tables is a sorted string table implementation, which is basically just a big key value pair created by Farsight Security. They use MTables for passive DNS databases, so storing like massive amounts of DNS records per day. I use it to basically create giant key value data stores for each of these data sets we download, and I do it by basically taking any data set that I get and turning it into a key value pair by structuring the keys very specifically. So IP addresses, for example, I just store in the normal format, and they're actually pretty easy to query from there. But for things like domain names, you have to reverse them. You have to store them as com.something.something.something. And so if you want to find everything within a com space, you do com.domainname.star, basically, to find everything below that key, because you can only do forward lookups with these key value databases. So as long as you structure your data right, you can find really creative ways to create a key that makes really fast lookups. But sometimes it's cheaper to create more than one database, a forward lookup and a reverse lookup, as opposed to using some more like a Postgres database or a standard relational database. I can tell you that when I started really diving into this a couple of years ago, nothing really scaled past 1 billion records on a single machine without falling over. Mongo was probably the worst thing I looked at, and then everything else was some level of crap below that. Postgres, you can technically get it there, but you're probably not going to get it there in a single box that you can put on your desk. One thing I like about MTables is after you finally built these damn things, you can run them just fine on a laptop with 8 gigs of RAM. And you can query a 1 terabyte database, and there's no overhead, there's no running daemon, there's nothing. It just nmaps the database, seeks into the index and looks them up real quick, and you're done. So there's no real overhead using MTables. There's no running process, no running daemon, there's no maintenance, there's no backups. You basically just copy some files around and you're good to go. One of the great things about MTBL 2 is it has multiple compression formats. The default's snappy, but you can even use LZ4. So it ends up compressing a lot of the raw strings in the data very cleanly and really very small as well. So oftentimes the MTBL output is half the size of the source format, even if you have to create multiple versions of it. Let's see. So the challenge with MTBL is there's not like any real good ways to query it. And so I built a query tool in Golang called MQ. That's part of the unnamed data parsers repository. And this handles all the weird idiosyncrasies between the key value format itself and being able to do things like a domain lookup. So when you pass it like -domain something.com, it's going to flip that key to the reverse mode and look it up in the reverse key store. It's going to assume the domain name itself and the host names have been stored in reverse order and then do that automatically for you. Same thing with the CIDRs. Even though internally it's stored as like a text 8.8.8, it'll actually break that up into basically pattern matches and then look up the right keys below that. And so if you give it like a single IP, for example, it'll just look up that individual key record. But if you give it like a /24, it'll look up 8.8.8.star. And then if you give it anything smaller than a /24, like a 27, it'll do internal filtering of the CIDR there. So it's probably too much detail for this, but long story short, you can use this to do CIDR lookups, domain lookups of any of these data sets we're going to talk about, pull out just the keys, just the values, raw format or JSON format. And it's generally kind of a Swiss Army knife for searching all the output that we're going to talk about here. So if you take something like the Census.io IPv4 data set, which is like probably 1.1 terabytes right now, compressed LZ4, it'll probably turn into about a 2 terabyte MTBL database, but you still only need about 8 gigs of memory to query that on your laptop. And even if it's on a spinning hard drive, it's still pretty fast because the index itself will fit into RAM. So anyways, long way of saying there that you spend a whole lot of time getting the databases in the right format and really optimizing the build process, but once you actually want to use them, they're really fast and they work well on commodity hardware. So I was worried I was going to burn through my talk too fast, and now I think I'm a little bit behind, so I'll try to catch up here. So we talked about this already. Basically, if you want to grab Census.io, make your own version of Shodan locally, go grab the raw data, install liblz4 tool, and then run the download.shell-s census.ip4, convert it, and it may take some time to do it. When it's all said and done, there's an example down here at the bottom where it shows doing a lookup for the 8880/24 subnet all at once, just a single lookup. So you can pull basically the Census.io results for a whole subnet instantly on a local laptop without much RAM once you've basically baked out this MTBL file. Things that aren't in MTBL format are probably JSON-L, which is kind of a line-delineated JSON structure. These are kind of ugly and they use up a lot of space, but they end up being a lot easier to parse than something like XML. You can grep them, line-based grep. You can pipe them things like JQ, JSAuc, DAP. So unnamed data will automatically convert all of your ARIN XML data if you sign up for a subscription, turn that into these JSON-L files that you can then grep out really quickly. So you're trying to get a list of all the email addresses for any point of contact within ARIN. You can dump them all out really quickly to JQ. And in this case, I found all the cities of anybody who had a Microsoft.com point of contact address in ARIN itself. So it makes it super easy to grep this stuff. So that's one of the other formats I use for a lot of the unnamed data work. And then for everything else, it's a text file. Because at the end of the day, you want to import something to Excel, you want to send it to a friend, you want to load it into MySQL, you want to load it into Postgres, you want to stick it in Mongo, you want to throw it into Elasticsearch. Almost every data file, at least the raw data files, end up being stored in plain text format and make it really easy just to kind of go from there. So on that note, move on to a little bit on storage. If you're looking at these particular data sources, ARIN, for example, will use about 8 gigabytes per day. Which is a whole bunch because you're turning XML to JSON-L. It could be better compressed, of course, but that's about where it's at. Sonar is a little bit bigger because you've got the reverse DNS, the forward DNS, and then you've got the inverse and forward lookup tables and the raw data and the CSV files that it creates as part of it all. You get a ton of value out of these things, so they end up eating about 200 gigs a week. You don't really have to keep old ones around if you don't want to. The most recent one's usually the best one. I usually keep about a month or two for my kind of hot systems. CZDSS is about 1.5 gigs, Premium Drops 4.3, WWS.io is about 6.5. Census is really the only one that's really big. That's about 3 terabytes per snapshot, and they do daily snapshots. And that's including the raw file plus the converted M tables and intermediate artifacts. If you want to go kind of pick and choose which particular data file you want to mess with or download or crunch, you can basically just give -s and the particular source name or -l the list of sources, and it'll give you a list of all the options there. After doing this for about 2 years or so, I'm about 30 terabytes in. I've got a whole bunch of NAS arrays and backups my backups and cloud backups my backups, but you don't have to go quite so overkill. I've set up the system for 3 clients now. and they were able to do it on a box with, I think, 10 terabytes on the first one, 2 terabytes on another one, and 1 terabyte on the third one, just by having it on a cheap little laptop in the corner. So as long as you trim your data, you don't really have to go overkill with the stuff. You just basically keep track of your most recent data sets and then process them once you download them and delete them when you're done. So the whole point of this kind of long diatribe about a bunch of scripts that download stuff and process it is being able to actually do cool things with it. So the whole goal of this is being able to do really fast lookups by domain name, by IP range, and there's lots and lots of common data sets. Like I use this thing probably 5 times a day for work all the time, whether I'm doing a pen test, whether I'm helping a customer scope something out, whether I'm just doing market research into something. I use this data set all day long every day. So that was kind of the driver to submitting a talk about it, is I feel like it's useful enough other people should get access to play with it. So easy thing, of course, is if you want to try to find all host names within a domain name, you can do that MQ query with -domain and query the CT files, the Sonar DNS files, premium drops, wws.io, lots of different things you can query to get a list of all the domain names out for a given thing. Same thing for the IP addresses. One of the neat things about taking those raw data sources and flipping them on their head, instead of doing most of these data sources start off being a host name followed by, the IP address or some other chunks of information that point to it. What I do with most of the data set so far is I keep that forward lookup, then I split it and take all the values and then sort the values based on the keys they're associated with. And now you can sort saying, okay, what domain names have ever pointed to this IP? So the reverse lookup part of that ends up being really useful. You can find every domain that uses the same DNS server. You can find every domain hosted on a particular IP address. So if you want a list of all the vhosts in a given subnet, it's super fast and it works like a charm. And you can find some really obscure stuff that way, like third-party domains that point to the same server or old marketing domains that you weren't aware of. Fun stuff, though. Same thing for SSL, TLS sites. If you're doing typo and keyword matching, you can just run your scripts against all the premium drops and wws.io data sets every morning. So you're trying to find someone setting up phishing sites against your organization. That's a quick way to automate that. And those tend to be really cheap and easy to pull. If you splurged on the Whois XML API, you can go through and scan all of those downloaded files for any registrant with the same email address. So if there's a kind of sketchy domain that got registered, you can go find all the other domains as part of it without having to go give domain tools $4,000. And one of the things that I really like about, and the reason why I keep so much of this data around, is the historical access. I really want to know who owned a domain at a given time and a given date, and what IP address, like who actually owned this IP address and what ISP it was associated with, what services were open on it, what its reverse DNS was. That information changes so quickly that a lot of the kind of threat intelligence tools out there do a terrible job. They assume that once you've seen an IP, that IP is all that IP. They don't tell you that, hey, this IP is no longer, it doesn't even belong to the same ISP 3 months later. So having historical ownership has been a really great way to tear apart some of the terrible threat intelligence research reports out there, or to figure out what of the reports that we're seeing are actually accurate, which ones aren't. But you can't really do that unless you know the time window that they identified as the threat, and you also have correlating ownership information for that same time window. So that's basically it. Once you've bootstrapped this thing, basically we're running daily.shell once, add it to the cron job, add any scripts you want to monitor, match, notify, dive into all the, we'll dive into all the particular scenarios here going forward. But this stuff just ends up being super useful. So all I can really recommend is, grab an old clunky server, shove some tools on it, let it run for a little while, and, ping me if you have any questions about what we can do with it or how to automate stuff. But I'm going to keep working this thing for the indefinite future, so happy to collaborate on things as well. So with that, I kind of move on to the next thing here, which is certificate transparency. So I don't know how many people have spent a lot of time on certificate transparency before. In previous kind of small local talks I've given, it wasn't something a lot of people really knew about or cared that much about. CT is a Google project to track all visible SSL certs and TLS certs on the internet. So some ISPs will actually, some CAs are required to submit all of their newly registered certificates directly to CT. CT is a whole bunch of independent servers on the internet that people can submit new logs to or new certs to, and they get added kind of like a blockchain, more of a Merkle chain. So they're a append-only list that you can then query and say, tell me everything you've ever seen. This is kind of a public write-only archive of the whole internet's TLS infrastructure. And it's really useful for a lot of stuff. It's good to make sure that CAs aren't issuing certs that they shouldn't be and selling off like intermediate leaf certs to people they shouldn't. There's been a couple certificate authorities kicked out of Chrome and Firefox now because of things that they did that were caught by CT. So CT is pretty much the enforcement whip for Google Chrome and to some extent Firefox as well in terms of how they look at what CAs they'll support. Komodo, even though they didn't have the best track record going into this, they spent a whole lot of money and time building this thing called crt.shell or crt.sh, which is a kind of looking glass search engine into the certificate transparency backend. So if you want to just be able to query the stuff without having to go set it all up yourself and pull it all down, crt.sh is a great way to do that. And you can do wildcard queries there as well. You can do %sign .domain name. It'll tell you every SSL cert for that domain name you've ever seen. So it's kind of a fun third-party service if you want to get a feel for what the data is like without jumping in with both feet. So the cool thing about CT is anyone can operate a log. You can build your own log server. You can take the standard source code, run it, and then advertise it and say, hey, send me your certs. There's a bunch of known logs out there that have very particular purposes. So, for example, the pilot log, as far as I can tell, is only used for Let's Encrypt. Let's Encrypt will submit all of the newly issued certs to the pilot log. So if you want to track what's being issued to Let's Encrypt, you pull that from that log. If you look at the known log list, they'll give you an idea of what the purpose of some of these ones are. And each of these log servers supports a bunch of different API endpoints, and there's no authentication for this stuff. It just they may reject your submission if it's not a valid cert chain or it doesn't match the purpose of that particular log. But in general, anyone can query any server. One of the reasons why certificate transparency is really important is that for every extended validation certificate generated by a CA, it must be submitted to 2 different CTs, or Chrome will not support that CA. So by definition, every one of those high-value sites out there that has an EV cert has to be in CT by definition. Otherwise, Chrome will stop trusting the CA. So between this and Let's Encrypt, that's the main drivers for why these CT logs are really important for discovery and for lots of other stuff we'll dive into in a second. But the cool thing about this is you can see all of these staging sites, pre-production sites, development environments, all the stuff that most people don't realize is being exposed because they're getting the cert before they turn the site on, and the site's not really ready yet. And that's kind of a recurring theme as we go through this a little bit. So just like extended validation certs, Let's Encrypt sends all of their new certificates to the pilot CT server. And as the market share of Let's Encrypt keeps increasing, that's going to happen more and more and more. And as people are adding integrations to Let's Encrypt for things like Docker, Kubernetes, Ansible, like all the different, Puppet, all these various tools that depend on having HTTPS communication or deploying servers that require HTTPS communication, are using Let's Encrypt because it's free and cheap and easy to manage as long as you handle renewals properly. The great thing about this, though, is as those dynamic infrastructure tools start using Let's Encrypt, they now become discoverable in real time. We can now almost in real time identify new assets as they're being deployed, oftentimes before they've been configured the way they should have been. So just a quick graph of the growth of Let's Encrypt. It's not changing anytime soon. The little drop here is because they changed methodologies in terms of how they track it, but Let's Encrypt is positioned to take over pretty much all of TLS. This is number of domains, and this is number of certs issued per day. So if you want to, one of the fun tools that's part of the iNet data repository is iNet data CT tail. You can literally just run this utility, and it'll just spew out all the certs as they're being registered directly to your terminal. And then you can pipe those out to lots of other fun things. So I'll put the slides online later. You can look at the recording, but essentially grab the tool, start running it and start grabbing for whatever weird thing you want to look for. And you need to put a Bloom filter in front of it to deduplicate it without using lots of RAM, but that's pretty easy. It'll be in the slide notes how to do that. Then feed all those outputs, all the output of that directly to whatever scanning tool you want. So either whether you're looking just for your domain or whether you're looking for a customer's domain or everything on the internet, it has a lot of fun stuff. So the cool thing about this is because Let's Encrypt certs are often issued before the application itself has been fully set up, there's this fun little race window or fun little race condition in the timing. A lot of web apps provide admin access to the first person to go to the site when it's being set up. But the site doesn't have SSL cert yet. So what do you have to do? Wait to go to Let's Encrypt to get an SSL cert before you bring the app up. But when you bring the app up, it's not being configured yet. So if you're able to basically snipe these websites before they've been configured, as the cert's being submitted directly to Let's Encrypt from the CT logs, you can actually race the admin and steal their server, backdoor it, reset it, and then have permanent access to the server. And this works really, really well. I'm actually running it in real time right now. So here's an example of all the sites that are deploying things like, let's see, there's a WordPress site that was just launched with still misconfigured or still unconfigured. Another one up here, a bunch of Drupal sites, a bunch of trees. There's a bunch of them there. Anyways, there's all those various third-party web apps out there that are known for having lots of vulnerabilities. All generally do a first-time setup process, and those things are easy as hell to scan and exploit using the CT tail tool, followed by some quick fingerprinting. So this big, ugly, nasty command line will go grab the HTTP title of every site being pulled out of the CT tail, and then basically run it through Nmap's HTTP title grabber. And all you do is just basically tail them, look for the logs coming out, and just log in and steal their server. It works really well. So here's an example of a WordPress box that I ran into earlier. All these demos are from earlier today. They're actually running real time now in the background as well. Yep, just go through and steal it. And then a bunch of other web apps I found about an hour ago, just tailing directly from CT logs. So there's something definitely broken with how people roll out their web apps today, especially some of these different ISPs that will enable Let's Encrypt to get an SSL cert, but then don't force, they don't limit access to the application at that point until it's been set up. So there's lots of there's a fun little race condition there you can mess with. So with that, I'll move on. I know we're a little short on time, so I'm going to go ahead and move into cloud discovery stuff. There's a fun trick you can use with Azure, where if you look under the cloudapp.azure.com domain, you can find all the wonky CNAMEs for Azure assets. So if you're trying to figure out where a particular asset is being hosted or what type of server it's on, you can then pull it directly out of these. Same thing for security transparency. This also highlights that the Sonar DNS dataset has 8,500 or so of these, but the CT dataset has about 2,865, and they don't actually overlap that much. For some reason, the way that Sonar is gathering its dataset and the way that CT's certs are being issued, you kind of have to combine both of these together to get a full view of what's going on. You can also sometimes find leaked host names for internal.cloudapp.net, which is how the internal DNS in Azure works. And you can basically use that to attribute a given Azure asset back to the organization that owns it. So move on ahead to domain fronting. I can't see the audience, but I'm assuming some of you guys know what domain fronting is. It's a fun way to use respectable domain names to run your C2s out and bypass most exfiltration tools or exfiltration stopping tools. You can use all the MTables that are generated by data to find all of those. So here's how to get all your Azure stuff. It's a couple command lines. You get just a big old dump of all the host names you can use for it. So you want to find the more obscure, lesser overused domain fronting domain names. You can use PepsiCo, you can use Shama, all kinds of stuff. Same thing for CloudFront. Easy to grab those. Just basically grab the MTables, scan it for cloudfront.net, pull it out, and there you go. And again, for Fastly, same thing. So you can do this for Google, you can do it with AWS. I didn't finish up all those examples. I don't want to bore you to death, but if you do domain fronting a lot, this is a quick way to get all your domain fronting names. To give you an idea of kind of other use cases for it, in the case of discovery for M&A, if you look at these individual sources, you've got 17 names out of FDNS, 4 out of RDNS, and 10 out of transparency, but you combine them all together, you get 20 host names. So it usually makes sense when you're doing discovery for either M&A or as part of a discovery or scoping task to use multiple data sources, combine them all as part of how you generate your initial scope. If you're looking at a domain with a lot more domains, like McAfee, for example, this kind of demonstrates that there's not a whole lot of overlap right now between Sonar and Certificate Transparency and other third-party sources. I didn't get the stats for passive total, but in general, all these different data sources tend to have totally different results and totally different sets of results and things that are missing and not missing. So it makes sense to combine them as much as you can. So quick summary is having a giant local database of all these internet data sets can really improve your security stuff. Everything from discovery, monitoring, exploitation, exfiltration. The costs are really low compared to how much cost how valuable the stuff is, especially if you have to pay someone else to run it. And it's easy to keep your client information safe if you're not submitting it to third parties. So just roadmap stuff, lots more data sources, more normalizers, more real-time streaming sources, Inodata CT tail, PDNS, performance improvements, and so on. I would love help on this. If anyone's interested in contributing to this stuff, drop me a line after the talk, and happy to collaborate on who builds what, when, where. It's all under an open source license. I think it's MIT at the moment. Half's in Ruby, half's in Golang right now. It'll probably all eventually be Golang at some point. But yeah, use this to build out your own API, build up your own thing, monitor your company stuff, or do a bunch of research and do a talk on it. And with that, I think I got a couple seconds here. I can do quick demos. 5, okay. So I'll go ahead and get some demos up real quick, just to kind of show you what it looks like, and just to get a minute or two. So this is kind of a live CT log tail. We actually just run the CT utility. Let's see, I think it's on the screen. Yeah, there it goes. Here's the full command line for CT tail, but if we just run CT tail itself, and then, let's see, run that through a Bloom filter, here's basically a live run of all the host names being registered to CT in real time. So these are all host names being pushed directly out to the SL infrastructure as they're happening, which is awesome. So it's kind of cool to see those. Let's see, there's a couple other examples here for, if you want to say, let's see, find, may have another terminal for that. Yeah, so if you want to say, find me every domain server on the internet where it's where the domain server itself ends in .ru, you can get basically all of Russia's domain servers in one shot. and all the domains that point to them. So lots of little fun things. All the tools here that work on domains also work on entire TLDs at a time. So if you want to do like internet scale kind of research stuff, this is all really very well set up for it. You can do small domains, big domains, lots of little bits of data. That's it. I think that's probably it for demos as far as time goes. At this point, it probably makes sense to switch to questions.
All right. HD, can you hear me? Can you hear me, HD?
Yep, good.
Questions? No questions? No questions? Oh, we have a question.
So you covered that you're covering all footprints of any company. Have you found any case where you missed one domain or one IP address because it was not captured in Sonar or it was not captured in certificate transparency or any other place? Like it's not all, it's most of the things you are covering through 30 terabytes of data. Was there any case like that?
Yeah, there's usually cases. The echo's pretty bad. I'll just try to talk through it. Cool, thank you. Yeah, there's definitely cases out there where the things that are in third-party databases, whether it's password total, Sonar, or whatever, they generally miss stuff. That's why combining lots of sources gives you a better perspective on it, and you still generally want to use some active discovery. If you're doing a brand new pen test and you haven't looked at the network before, definitely grab your CT data, your Sonar DNS data, but also look at password total, also do your active enumeration, your go busters, your fierce, your subroot, all that, because you can definitely miss things that way. All it takes is a couple drop packets for those large data sets to totally miss a domain.
I don't think there are any other questions. Thank you.
Okay, awesome. Thanks, folks. Appreciate it.